Hi everybody, here's question 61 from chapter 9. This question asks for some Lewis structures for four different molecules. I'm going to do two of them here with you, and then after that, like if you have any questions about the other ones, you're welcome to email me and such, but these are kind of a rinse, wash, repeat sort of thing, so long whenever the octet rule thing works out. So we're going to do exactly the same thing in terms of formal charges and all that sort of stuff in each of these. So let's get to it. Let's do selenium dioxide to start. All right, so selenium dioxide. Okay, formula for this is really easy. You take the number of valence electrons that you need in total, and each of these here need 8. So that is 3 times 8 gives me 24. And then subtract the amount of electrons that are actually supplied by these species, which is 6 for each of them. So that is 18. And divided by 2. And this will give you the amount of bonds that you need, so long as the octet rule is working out. So this gives us 6 over 2 is 3 bonds. All right. So 3 bonds in this case. So we're going to expect a double bond on one side and then a single bond on the other. And we'll just add our electrons where we have to. Okay. And we'll have to add one more to selenium here. So that'll be 8 there. 8 there gives us 16. Plus the 2 here gives us 18. So that is excellent. I'm just going to move that a little more over selenium. And let's do some formal charges. Okay, so for the formal charges for oxygen with 1 bond, these are always -1. And for the ones where it's bonded twice, it's 0. We can show those pretty easily. So oxygen with 1 bond, this is amount of electrons in the valence, which is 6 in this case, minus the amount in free pairs, which is 6, minus the amount of bonds, equals -1. So there's that one. Double bond oxygen. This is 6 minus, now you've only got 4 of them in pairs, and you have 2 bonds. So this is going to be 0. Now for selenium, same deal. How many you got in the valence? This is 6. 2 of them in lone pairs. We have 3 bonds in total. Gives us a formal charge of +1. All right, we're okay with this because we have the negative formal charge assigned to the more electronegative atom, and we're supposed to have a neutral charge for this molecule. We have -1 and +1 and 0, which equals 0 in total. So we're happy with this. All right, then the last thing you'd have to do is draw your resonance, which is this this double-lined, double-headed arrow here. Make sure, I don't know how particular your prof is with this, but this is not the same as the equilibrium arrow here, so make sure you don't draw them the same. And you would draw your double bond reversed in the second one, just like so, and tack on your extra selenium. All right, so that'd be the first one. That's selenium oxide. All right, next one we're going to do is carbonate, I believe. Carbonate, yeah, CO3 2-. So this time we get to incorporate some extra negative charge in this case and see how that changes things. All right, so we're going to do exactly what we did before. We got 4 of them that need 8 electrons apiece. That's 32 in total. We're going to subtract the 18 from oxygen, right? 6 times 3. And another 4 from carbon, so that gives 18 plus 4 is 22. We also have 2 electrons added on top, so to the 22 is going to become 24 when we add those in. And we'll divide this by 2 again. We're getting, and we get 8 over 2 gives us 4 bonds in total. So we're looking at another resonance structure here. We're going to be double bonded one direction and single bonds the others. All right, let's add on our electrons. Okay, double check this balances out. I didn't do this in the last one, but I have 8 here, 8 here, 8 here. That's got to equal the amount of electrons we actually have present. So this works out. Formal charges, you saw me do these ones for the last one, so you know there's going to be -1, and there's going to be -1, and there's going to be 0 here. We will calculate the one for the carbon, because we haven't seen that species yet. So 4 valence electrons, 0 free pairs, 4 bonds equals 0. All right, so that is a happily neutral carbon. Okay, this thing has a charge on it, right? So we didn't draw the square brackets for the selenium dioxide because there wasn't a charge, but now we've got a 2- charge on this whole thing, so that is necessary. And then you do your double-headed arrows. In this case, because you've got 3 ligands on the carbon, right? Ligands are whatever is attached to your central atom. Then you're going to need to do this twice. All right? I'm only going to do it once, but you guys would, on an exam, or if I was writing your exam, I would definitely be doing it twice. Like such. Minus, and then you would draw your last one over this way. All right, that is how these are done. That formula is always the same, like I said, so long as the octet rule is working. So if you have any questions at all, you can email me. Otherwise, good luck with your Lewis structures.